High-voltage transformers specifically designed for floating platforms are central to this type of installation. These transformers convert the 480 volts power supply to 12 kilovolts and are typically mounted on pontoons or platforms at the water's edge. Submersible cables are crucial for connecting the transformers to the utility's power distribution system. These insulated, waterproof cables ensure a reliable and safe connection beneath the water surface. Distribution cables, which are insulated and weatherproof, then run from the transformers to the marinas' electrical outlets, providing power to boats and other equipment. To ensure public safety, several measures are essential. Firstly, ground fault interrupters, or GFIs, are installed throughout the system. GFI are designed to detect and interrupt electrical faults, thereby significantly reducing the risk of electrocution. Secondly, all electrical equipment, including transformers and cable connections, must be housed in watertight enclosures. These tamper-proof enclosures prevent water damage and protect individuals from accidental contact with electrical components. Thirdly, flexible connections are used for the cables running between the transformers and the marina outlets. These flexible connections accommodate the movement of the floating platform and the boats, preventing stress on the cables. Fourthly, warning signs and markers are prominently displayed to alert boaters and marina guests to the presence of high-voltage electrical equipment and the potential risks. Fifthly, regular maintenance and inspections are essential for ensuring the safety and reliability of the electrical system. Utility assurances are another critical aspect of the design change. Firstly, the serving utility must approve the design and specifications of the entire system. This ensures that the system complies with the utility's standards and safety regulations. Secondly, close coordination with the utility is necessary to determine the appropriate connection points, capacity requirements, and protective measures. Thirdly, the utility may require the installation of equipment that meets specific safety certifications to ensure compliance with industry standards. Fourthly, the entity requesting the design change should obtain comprehensive liability insurance to cover potential damages or injuries that may result from the installation or operation of the system. Additional considerations include, firstly, the potential environmental impact. The county should assess the environmental effects of the submerged cables and floating platforms on marine life and water quality. Secondly, obtaining the necessary permits from local authorities is essential before commencing the project. This ensures compliance with all local regulations and standards. Involving local residents and stakeholders in the planning process can help to address any concerns and build support for the project. When installing floating transformers, several factors must be considered to ensure safety and reliability. The transformer should be specifically designed and rated for marine environments capable of withstanding humidity, corrosion, and wave action. Proper grounding and bonding are crucial to minimize the risk of electric shock. All metallic parts of the transformer and the floating platform should be bonded together and connected to a grounding electrode system. Overcurrent protection devices, such as fuses and circuit breakers, must be installed to protect the transformer and downstream circuits from overloads and short circuits. Surge arresters should be installed to protect the transformer from voltage surges caused by lightning or switching operations. Regular inspections and maintenance of the transformer are essential to identify and address any potential problems such as corrosion, insulation degradation, or loose connections. The submersible cables that connect the floating transformers to the shore-based power grid must be specifically designed for underwater use and comply with relevant industry standards. The cable should have a robust insulation system that is resistant to water penetration, abrasion, and chemical exposure. Cable sizing should be adequate to carry the required load current without overheating, and voltage drop should be within acceptable limits. Proper cable support and strain relief should be provided to prevent excessive stress on the cable terminations. The cable should be buried or otherwise protected from physical damage, such as boat anchors or marine traffic. Regular inspections of the cables are necessary to detect any signs of damage or deterioration. The distribution cables that run from the floating transformers to the marina's electrical outlet should be suitable for use in wet and corrosive environments. The cable should have a waterproof jacket and insulation system to prevent water ingress. Cable sizing should be appropriate for the load requirements of the Marina's electrical outlets, and voltage drop should be minimized. The cable should be installed in conduit or cable trays to provide mechanical protection and prevent physical damage. All cable connections should be made using waterproof connectors and sealed to prevent water ingress. Regular inspections of the distribution cables are necessary to identify any signs of damage or corrosion. Ground fault interrupters, or GFIs, are essential safety devices for marine electrical systems. GFI are designed to detect even small amounts of current leakage to ground and quickly interrupt the circuit, preventing electric shock. GFI should be installed at all Marina electrical outlets and in any areas where people may come into contact with water. The GFI should be tested regularly to ensure that they are functioning properly. The sensitivity of the GFI should be appropriate for the application, typically 5 mA for personnel protection. GFI should comply with relevant safety standards such as Underwriters Laboratories 943. Watertight enclosures are necessary to protect electrical equipment from water damage and prevent accidental contact with live parts. The enclosures should be made of corrosion-resistant materials such as stainless steel or fiberglass. The enclosures should be properly sealed to prevent water ingress, and all openings should be fitted with waterproof glands or fittings. The enclosures should be sized appropriately to accommodate the electrical equipment and provide adequate ventilation. The enclosures should be installed in locations where they are protected from physical damage, such as impacts from boats or equipment. Flexible connections are used to accommodate the movement of the floating platform and prevent stress on the electrical cables. The flexible connections should be made of a durable and waterproof material such as flexible conduit or cable. The flexible connections should be long enough to accommodate the expected range of motion of the floating platform. The flexible connection should be properly supported and strain relieved to prevent excessive stress on the cable terminations. Regular inspections of the flexible connections are necessary to detect any signs of damage or wear. Warning signs and markers are essential for alerting boaters and marina guests to the presence of high-voltage electrical equipment and the potential risks. The signs should be prominently displayed in areas where people may come into contact with the electrical equipment. The signs should be made of durable and weather-resistant materials. The signs should use clear and concise language to communicate the potential hazards. The signs should comply with relevant safety standards, such as American National Standards Institute C535. Regular inspections of the warning signs and markers are necessary to ensure that they are in good condition and properly visible. Regular maintenance and inspections are essential for ensuring the safety and reliability of the marina's electrical system. Maintenance should include tasks such as tightening connections, cleaning equipment, and replacing worn or damaged parts. Inspections should include tasks such as checking for corrosion, water ingress, and insulation damage. Maintenance and inspection should be performed by qualified personnel who are familiar with marina electrical systems. A record of all maintenance and inspection should be kept. The serving utility plays a crucial role in ensuring the safety and reliability of the marina's electrical system. The utility should review and approve the design and specifications of the system to ensure that it complies with their standards and safety regulations. The utility should provide guidance on connection points, capacity requirements, and protective measures. The utility may require the installation of equipment that meets specific safety certifications to ensure compliance with industry standards. The utility should conduct inspections of the system to ensure that it is properly installed and maintained. Obtaining the necessary permits from local authorities is essential before commencing the project. The permits may require compliance with local building codes, electrical codes, and environmental regulations. The permit application should include detailed plans and specifications for the electrical system. The permit application should also include an environmental impact assessment. Community engagement is important for addressing any concerns and building support for the project. The community should be informed about the project and its potential impacts. The community should be given the opportunity to provide feedback and ask questions. The project should be designed to minimize any negative impacts on the community. The design of the floating marina power system should also consider the potential for voltage fluctuations and harmonics. Voltage fluctuations can cause equipment malfunction and damage, while harmonics can cause overheating and reduced efficiency. To mitigate these issues, the system should include voltage regulators and harmonic filters. The voltage regulators should maintain a stable voltage level, even under varying load conditions. The harmonic filter should reduce the level of harmonics in the system. The installation of the floating marina power system should be performed by qualified electricians who are experienced in marine electrical work. The electrician should follow all applicable codes and standards. The electrician should use proper grounding and bonding techniques to minimize the risk of electric shock. The electrician should thoroughly test the system after installation to ensure that it is functioning properly. The ongoing operation of the floating marina power system should be monitored to detect any potential problems. Monitoring should include tasks such as measuring voltage, current, and power factor. Monitoring should also include checking for any signs of overheating or equipment malfunction. Any problems that are detected should be addressed promptly. The floating marina power system should be protected from lightning strikes. Lightning strikes can cause severe damage to electrical equipment and pose a serious safety hazard. To protect the system from lightning strikes, lightning arresters should be installed. Lightning arresters should be connected to a grounding electrode system. The floating marina power system should be designed to be energy efficient. Energy efficient design can reduce energy costs and minimize the environmental impact of the system. Energy-efficient design measures include using energy-efficient transformers, cables, and lighting fixtures. Energy-efficient design also includes using power factor correction equipment to improve the power factor of the system. The floating marina power system should be designed to be resilient to extreme weather events. Extreme weather events, such as hurricanes and floods, can cause significant damage to electrical systems. To make the system resilient to extreme weather events, the electrical equipment should be located above the floodplain. The electrical equipment should be protected from wind damage. The electrical cables should be buried or otherwise protected from physical damage. The floating marina power system should be designed to be easily maintained. Easy maintenance can reduce maintenance costs and minimize downtime. Easy maintenance design measures include using readily available components, providing access to equipment, and labeling all components. Easy maintenance design also includes providing clear and concise documentation for the system. The floating marina power system should be designed to be safe for both people and the environment. Safety design measures include using ground fault interrupters, watertight enclosures, and warning signs. Environmental design measures include minimizing the use of hazardous materials, preventing pollution, and conserving energy. The design and installation of a floating marina power system from 480 volts to 12 kilovolts requires meticulous attention to safety, regulatory compliance, and environmental considerations. Employing qualified professionals, adhering to established standards, and prioritizing public safety are paramount to ensure a reliable and secure electrical infrastructure for the marina. These high-voltage systems demand specialized expertise, and it's essential to engage with experienced engineers and contractors familiar with marine electrical installations. The proposed design change from 480 volts to 12 kilovolts introduces complexities that must be addressed comprehensively. The higher voltage necessitates enhanced safety measures and stricter adherence to codes and standards. It's important to understand the rationale behind the voltage increase. Is it to accommodate increased power demand at the marina, reduce transmission losses, or improve system efficiency? Understanding the objectives of the change will inform the design process and help to ensure that the new system meets the marina's needs. The serving utilities' involvement is absolutely critical. Their approval of the design is essential, as they are responsible for the safety and reliability of the power grid. They will have specific requirements for the connection point, protective devices, and metering equipment. Early and frequent communication with the utility is key to avoid any delays or surprises during the project. The selection of equipment for a floating marine environment requires careful consideration. All electrical equipment must be rated for marine use and capable of withstanding the harsh conditions of saltwater, humidity, and wave action. Transformers, switchgear, and cables should be specifically designed for marine applications and certified by a recognized testing laboratory. Grounding and bonding are of paramount importance in a marine environment. The grounding system must be designed to minimize the risk of electric shock to boaters and marina personnel. All metallic parts of the electrical system, including transformers, switchgear, cables, and boat hulls, must be properly bonded together and connected to a grounding electrode system. Protection against overcurrents and faults is essential to prevent damage to equipment and ensure safety. The electrical system should be equipped with appropriate overcurrent protection devices such as fuses and circuit breakers to protect against overloads and short circuits. Ground fault protection should be provided to detect and interrupt ground faults, which can be particularly dangerous in a wet environment. The installation of submersible cables requires specialized techniques and equipment. The cables must be properly supported and protected from mechanical damage. The cable terminations must be sealed to prevent water ingress. Regular inspections of the cables are necessary to ensure their integrity. The design of the mariner's electrical distribution system should consider the load requirements of the various boat slips and other facilities. The system should be sized to accommodate the expected load growth. Voltage drop should be minimized to ensure that all equipment receives adequate voltage. The marina should have a comprehensive electrical safety program in place. The program should include regular inspections, maintenance, and testing of the electrical system. Marina personnel should be trained in electrical safety procedures. Boaters should be educated about the hazards of electricity in a marine environment. The potential environmental impacts of the floating marina power system should be carefully considered. The use of oil-filled transformers should be avoided if possible, as oil spills can have devastating consequences for marine life. The submerged cable should be designed and installed to minimize disturbance to the seabed. The marina should have a spill prevention and response plan in place. Obtaining the necessary permits from local, state, and federal agencies is essential before commencing the project. The permitting process may require compliance with environmental regulations, building codes, and electrical codes. The marina should consult with experienced permitting professionals to ensure that all necessary permits are obtained. Community engagement is important for addressing any concerns and building support for the project. The marina should communicate with local residents, boaters, and environmental groups to inform them about the project and solicit their feedback. The marina should be responsive to community concerns and make every effort to minimize any negative impacts. The floating marina power system should be designed to be resilient to extreme weather events, such as hurricanes and floods. The electrical equipment should be located above the floodplain. The electrical equipment should be protected from wind damage. The electrical cable should be buried or otherwise protected from physical damage. The marina should have an emergency preparedness plan in place to address potential power outages. The floating marina power system should be designed to be easily maintained. Easy maintenance can reduce maintenance costs and minimize downtime. Easy maintenance design measures include using readily available components, providing access to equipment, and labeling all components. Easy maintenance design also includes providing clear and concise documentation for the system. The floating marina power system should be designed to be safe for both people and the environment. Safety design measures include using ground fault interrupters, watertight enclosures, and warning signs. Environmental design measures include minimizing the use of hazardous materials, preventing pollution, and conserving energy. By addressing all of these considerations, the county can ensure that the floating marina power system is safe, reliable, and environmentally responsible.